All right. Welcome everybody. I'm waiting for my screen. Let's hope that works. Yeah, there we go. And as you can see, we're going to start with cargo clean. There we go. Just so you know, I'm serious. Let's see. I did make my build command a shell script, so I don't have to type it. But since last year, we have, of course, written a year of code, and Apple has made faster CPUs. So that turns out that our build time is pretty much the same as last year. So, yes. 8.5 seconds, clean build with all dependencies. I mean, that's nice, right? This is why you want a new MacBook. I mean, yeah, tell your boss and it's useful. So, let me boot up my slides. And I was honest, everything is going to be compiled from scratch once we do this. There we go. These are my slides in the IDE. So hello RustNL, visual application design in Rust. Yeah, when I decided to make this talk, or propose the talk, I always make some lofty goal and then I'll see how far I get. So, we got pretty far, but you'll see how far we got. We're building MakePad, and we're trying to bring back what we lost when we lost Delphi and VB. Not that I ever liked Delphi and VB as programming languages, because they were slow. I was a C++ guy, so I liked Visual C++, which had a dialogue editor, and that thing was absolutely fantastic to me, because that meant that I could prototype my ideas visually before I started to write code. The UIs looked terrible, but were very functional, because I could make buttons for everything. And so I want to bring that back, but for a new language, in this case, Rust, which is fast as C++. And you will not suffer null pointers, all those horrible things, memory corruption. So we're building a new IDE and a new design tool. The idea is to fuse the visual design. I mean, we're not in 1995 anymore, so we can't build a dialogue editor and call it a product. We have to go, okay, it has to at least do what Figma does, right? Or it has to be very visually expressive. It has to be very fast. And run everywhere. But why I want to do this is because I love having fun with code, right? This is why I started programming on an MSX, where you had circle and beep and play, and you could make it make sounds. And that was magic to me, right? That's what I wanted. Except as time passed, this simple way of interacting with a computer became harder and harder and harder, until the point where when you want to play a sound, you're like, no, not today, maybe tomorrow. So that is part of the mission of what we're trying to build, is that all these basic APIs like sound and networking and graphics are as easy as I can make it in Rust, which has limitations, but it's not going to be basic, but it has an idea. And as you know, I focus very much on compile time, because Rust has kind of a bad name, especially among C++ developers, that it's very slow to compile. I don't think Rust compiles slow at all. I think we're just loading it up with too much stuff, right? We're just adding too many dependencies that are completely thrown out, or like 99% thrown out. Like an example is the crate that Microsoft made, Windows RS. If you download that thing, no, it's great. I'm very, very happy that they made it. It's an amazing piece of engineering. They've wrapped their entire platform in generated Rust code that is actually Rust native. It feels Rust native. It iterators, async, everything works. That's amazing. The problem is that they just wholesale converted the entire platform API. So it's 360 megabytes of Rust, which is roughly modularized. So if you want to access a single function call from the Windows API to do something for your command line tool, everybody is going to just download all that, and then it churns through it, and then, I don't know, it takes like 45 seconds or something. Long time, but it's wasted. So for MakePad, what I did is I wrote a little regex engine kind of thing that just stripped Windows RS of everything that I didn't use. And so it's not a very nice tool. I wish that Microsoft would properly do this. But if you just look at the imports you use and then generate the platform from it, I was able for MakePad to run on Windows with all sorts of stuff, audio, video, windowing, clipboard, all that stuff. 365 megabytes or something went down to 1 megabyte. That's how much I used of the platform API. So if we can choose to generate these things in the future instead of like, whole hog converting it, then you get these 8-second compile times, also on Windows, also on Linux. But yeah, we have a strong focus on compile time. I'll get back to that in a bit. But they asked me, or they told me that we have side screens here. And I was like, side screens? Yeah, what do you want to do with the side screens? So I was like, okay, how about Apple TVs? So yeah, there's my Apple TV. Here we go. So this is tricky, right? I'm going to now deploy a Rust application to my Apple TVs. And it's using all of the signature stuff of Apple. And this is really kind of tedious because it phones home. It asks the server if it can sign a binary, and only then will it run on your Apple TV. So let's see if that actually works. Oh, deploy. Not deploy. Oh, all right. So of course this is the Arends thing, the synthesizer that I showed last year as well. I'll show it in a bit too. I can also compile so this is the fractal zoom on my main machine. Let's compile it to the Apple TVs. There we go. I would say it's fun to figure this out, but this is the part where you're like, okay, I do for my job. I get to have the fun later. So here we have the fractal zoomer, and this is MakePad Studio that I'm showing. I'll go into more in depth. This is what we're building essentially. This is the IDE. This is the Visual Basic that we're building, and here's the Mandelbrot fractal shader. MakePad is built on shaders. All of the UI is styled with shaders, but not in a like shader toy kind of way, but more in like every button is a rectangle and it runs a little shader program just for that button, right? I'm not drawing everything in a giant shader. That is horrendously inefficient. But look, I can now live code shaders on my Apple TVs, right? This is one of those things that I've been wanting to do for so long. Because the GPUs in these Apple TVs are really amazing. They're high-end phone SoCs that are in there, and you get an actual decent GPU for $150 or something. So it's an amazing device, but getting that as accessible as this, because I have projectors at home and I have these devices, and I was always like, why can't I live code a shader on that thing? Well, now you can, because Apple TVs don't come with a web browser. Apple just threw the web browser off the platform. You don't have a web browser, so you cannot open Safari and do some WebGL thing. You have to actually do all this work and have it run on Metal. So this is all running on Metal and it's transpiling. It has a WebSocket connection to the IDE. So all of the applications on all devices and platforms that we support run on, not Android today. I'm not going to do that. So let me show you. Here is the WebAssembly build of that fractal zoom. Let's make a WebAssembly build. Let's see if the WebAssembly build wants to do anything. As I showed you, I did cargo clean, so I have time to drink some water. Okay, let's see. Did we build it? Yeah. It doesn't take long either. So here's the fractal zoomer in a browser, but because I use WebSockets as the communications protocol, when I change this shader, it should just also work in the browser. So you can live code UIs across all of your devices at once. Note the UI DSL, not the code. The code is, of course, compiled using Rust, and that is a little bit more annoying. I'll show you what that means. Okay, let's turn off WebAssembly. So a concept in MakePad Studio that I really like, that I haven't seen very much elsewhere, is that you don't build, you turn a build on, right? A build is always on. So when you change code, it rebuilds automatically. So you just turn it on, and then it runs, and when you change the code, it just rebuilds it. So when I do Studio Release, now it's running inside MakePad Studio. This is running on a cross-process texture. That was really hairy to build, especially cross-platform. It's a little bit browser technology that you have essentially a child process that is completely isolated. GPU is running in the child process, so your operating system can, if you crash this shader, my IDE will survive it, which is not something that I have seen possible in a web browser because it has a GPU process, so you're going to crash the GPU process. Here, that's not the case, which is something that I really missed if you're building a real tool. So here's the fractal zoomer in the IDE, and now if I put my cursor, I'm not going to change the code. I'm just going to make it recompile. If I press space, okay, let me close my slide so it doesn't flicker. If I press space, you see that the application fades out a little bit and then restarts, right? This is as smooth as I can make live coding in Rust, right? You have to rebuild it, and it has to restart the application. You can serialize the state to disk and reload it after. That's something that we're working on. Like if you have an application model that supports that, then you can have a much more live experience because the state is serialized and reloaded and represented. But personally, I find this completely acceptable way of programming. Like if I take, it's not a very pretty one, but like if I take the simple example, yeah, we'll show that in a bit. Files. Simple app. No, not this one. This one. I abuse my example sometimes a bit to test stuff, so there's a lot of stuff commented out that has nothing to do with simple. So I click on Hello World, and it sends a message. So all of the logging is also done through the WebSocket. So if I have a phone, if I have a TV, if I have a web browser, I get all my logs in the IDE via the same route as that I update the live coding. But here you see, where's my code? It prints it. It says button clicked. So, right? It's I'm sorry that the UI is changing structure, but that's because of the feature I'm going to show in a little bit, which is the new design environment. So let me make it so that it doesn't bother me too much. Come on, tab. Go there. Okay. Right. So let's run it. The recompile cycle that I have with this feels to me almost like live coding, right? 1 second. That's okay. I think that's fine. And this is about as good as I'm going to make it with Rust. And with styling, so the reason that I separated the live coding for the UI and Rust is that code you usually think about a little longer, and it has many more failure states as you type it, right? So hot coding is fun if you have a really expensive startup cycle, like with a game engine or something that needs to do a lot of resources, and then you want that hot loading. But for applications and the applications that we're building, like an IDE, it's also fine. I can live code that as well. So here I can open MakePad Studio. In MakePad Studio, I've been developing MakePad Studio and MakePad Studio for quite a while now, and this is my developer cycle. As I go to Studio, I go to App. And then, I change a bit of code. 1, 2, that's it. That's my iteration speed for the IDE. And if I change something horribly far down in my library, like I changed the platform abstraction crate, right? This is the platform abstraction crate. 1, 2, 3, 4, 5. Yeah, that's it. That's the worst I'm gonna get in terms of iteration cycle. So Rust isn't slow. Rust is actually pretty fast, as long as you have a fast computer. This is an M3. I do like to, because this is the developer cycle that I want. I'm not ashamed to use a fast machine myself, because I'm already putting so much effort into making it as fast as possible. If you have a slow machine, I already did my best. It's not going to get any better. So I afford myself a fast computer, because that's one of the things, right? If you want to write fast code, get a slow computer. No. I also have to live, right? All right, let's get back to the slides. So yeah, the side screens are now showing something from 1980, right? This is not today anymore. Today we have other ways to play with computers, especially AI. This is even more complicated. I brought my own 4090 render machine here. So, okay, here we go again. Let's see. I'm going to first deploy the Stable Diffusion XL viewer to my Apple TV. Let's see. So, when you're playing with images, and when I had this AI image generator, I wanted to show it on my projectors, but I don't want to run a virtual desktop windowing, whatever cloud-based screen sharing thing. I just wanted to send the PNG over my local network via WebSocket to... oh, yeah, there we go. See, I even made the logo work. Before I did this, hold on. I was doing... no, not widgets. Experiments. Experiments is where I put all my stuff that you shouldn't look at, by the way, in my repo. It's not an example. Examples are slightly more curated. Experiments are just a thing so I don't have to have multiple Git repos. I don't like Git, so. Let's see. STXL remote. So I was trying to put that logo in the corner of the screen. So I was just like maneuvering it like this by just live editing. I was like, one of those moments where you're like, this is the moment I built everything for, putting the logo in the corner, right? All right, so so we have the Stable Diffusion thing now. I think it's now spamming my PC to connect to a WebSocket. Now we're going to run Stable Diffusion UI. This is another thing that I built in MakePad Studio. I'm gonna actually start the thing here, because as I said, MakePad Studio tries to live reload everything, and I'm going to continue, but the side screens are going to keep doing AI, so I want to run it separately. All of our build stuff is working via Cargo. All of the fancy build stuff like WebAssembly, Android, tvOS uses MakePad. Cargo MakePad is a Cargo extension. So yeah, we're rolling a lot of the build tooling in there. Hold on, let me see if let me say. So, say hi. Okay, this is Llama 3. So, this is an AI image generator. So, bright, sunny day. Okay, and then we're gonna render it, and we're gonna randomize the seed. Let's see if it's working. That would be nice if it's working. There we go. Oh, right. That's an artistic impression of you. I don't think well, whatever. This is the thing. This is an AI model, and it doesn't have much boundaries. So, if any of the content is questionable, wasn't me. So a bright sunny day. Right now we have a nice bright sunny day. But the thing is, if you're prompting in a social setting with an AI, this is a thing for parties, right? You just have people typing and then projecting it on walls, so you can play with an AI generator. In fractals, intricate, colorful. But this is very tiring, because you have to be creative, and you're too lazy to be creative. So it's like, what if we plug a text model onto this, so you can go, okay, I'm bored, just do something. right? And so I thought, okay, why don't we do llama? So describe yourself visually. And then it comes up with something. Oh, it didn't give yourself an identity. So you can talk to the AI about the prompt. Here we go. Let's see what... a bot. I don't think... well, let's start over. Trim, clear. Oh, in the style of a cartoon. Anyway, this is endlessly fun. I just wanted to show this as like, this is an application that I built in probably about a week in MakePad, because I was trying out, okay, how do we do networking? How do we do async? How do we build a form UI? How do we, how do I build a chat with an... I don't know. Yeah, okay. I'm happy that it's actually staying within the boundaries of acceptable, because you never know with this thing, right? But we're gonna... Let's... I don't know, I guess this is a nice and distracting set of pictures for the side screen. Let's keep that running. So, let's get to my slides. So, a nice thing now is that hopefully the AI will just keep going and I can use my IDE. So, oh yeah, I was going to show that as well. I have a camera input. Oh, this actually might be a really cool one to fade. So you can feed the camera from your webcam into the AI, and then the denoise is sort of like the blend between the camera input and the AI. So let's see what it does at denoise 50. Let's see. Okay. All right. I think it thinks that. Well, I mean, you can see the reference. So this is a little bit tricky, by the way. I'm going into dangerous territory now. But this is one of the best party tricks ever. I did this at a party, and at some point I was like, okay, I gave you the universe, right? And what do people do? They make themselves look like pop stars. Like, okay, all right, fine. But yeah, so essentially it becomes a Snapchat filter. Humans. So I'm not building this alone. I'm building this with my design co-founder Sebastian and Eddie Bruel for the hard things. That I'm just like, Eddie, can you figure this out? And he can do it. It's great because I like to go fast, and he does things like he fuzz tests. Right? That's, okay. I really want to do, yeah, okay. And then something comes out that is so rock solid that I never have to ask him anything ever again about it. So that's the cool thing about our cooperation with Rust, is that when he makes something, he gives it to me, I can refactor his code without asking him a single question. Right? This is a completely new experience for me when working together with other people on the same code base. And also the good thing about Eddie is that he writes code so thoroughly and slowly that it is extremely condensed. I'll bring up his latest achievement in a bit. So I want to show a little bit MakePad Studio. This is the main... how much time do I have? Because I meander a lot. Okay. 10 minutes? All right. So MakePad Studio, that's the thing that we're building, right? I just shifted the designer out of the way. Sorry if the screen's a little bit small. I have a 57-inch 8K widescreen monitor. And I stretched the IDE all the way like this. And then I have 3 code editors and a design tool and a running application, like on one wall, running at 120 hertz. And I'm like, okay, if you're building a future tool and this is the way it's going to be, then yeah, I'm pretty happy with that. So where's my design? Okay, there's the scene. It's the wrong way around. So let's change that a little bit. Ironfish, no. Okay, I'm gonna restart it. Ironfish, scene, design, yeah. So this is the Ironfish demo. We even added some presets now, so I don't have to difficult stuff or like arpeggiated. It's so much fun. Every time I open this, I spend like 15 minutes playing with it. But this is not a real application. This is just a test for me to see if I actually have a visual design tool. This is the graph of the UI tree in the running application. And the way I built this, because that was a long-running engineering problem, like, okay, how do you build this visual? Where do you put the visual designer? Do you run it in the IDE process or do you run it in the user process? And if you run it in the IDE process, you run into the problem that Visual Studio had, at least when I was playing with it, it was, I don't know, 15 years ago, with .NET, was that if you wanted to have user components in your visual designer, it had to load the user assemblies in the IDE, which is of course not very nice if you have custom components. For instance, this piano, that's not in my general widget kit, that's in the application. So, but you still want to be able to visually design it. So what I made is that the application is running in a texture, on a cross-process texture, but the designer also opens extra cross-process texture windows in the IDE. So it doesn't look like it's in the application, but this process, these things are in the application. Oh, I didn't want to show mobile. I wanted to show desktop. Also, I think that color picker is a bit in the way in my small screen. So because the designer is running in the user process, I can actually live edit the designer in the IDE, which is also very nice, especially if that's the main thing you're doing right now. Hold on. My editor is not really complete yet. Designer view, designer container, designer toolbox. I think it's the designer toolbox. Yeah, I need some better code folding. No. Where's my color picker? Also, I don't have search yet. It's a great anti-dementia thing, not having search in your IDE. Yeah, absolutely. As an aging developer, I recognize that is important. Button flat. So yeah, otherwise I would be able to search it. But this is also a nice little look at the DSL for the designer. The designer is built in the same structure as we're building the design thing with. Where's my color picker? Here's my color picker, right. So if I comment out my color picker, it goes away. Cool. But I wanted the whole rectangle to go away. Okay. So I'm gonna comment this out. I hope the indenting is all right. Oh, Sebastian put a lot of stuff in there. Oh, still there. Wait, I need to go one up. Oh. Okay, this is why I'm like, okay, the IDE is nice, but I need some new features like, group comment and all these things. Are we gonna go away now? My comment is nested. Oh, did I break it? Hold on. Gonna restart it. Are we restarting? Oh, okay. Maybe I pushed the demo gods a little too far now. Well, anyway, we're gonna do it without the color picker. I'm just gonna make it a little bigger. So this is the design canvas. And as you can see, it is essentially a splat out of all the components in the UI. It functions very much like a Figma design document of the application. So you can see all the instances of the components. By the way, this is also a feature that I'm very happy with. We now have on-demand SDF generation, thanks to Eddie B, not Eddie Bruel. He implemented an on-demand SDF font generator, and that is quite novel. It is invented by the guy from acco.net. You can look it up. SDF used to be very hard to generate because you had to generate a massive picture of 1K by 1K and then downscale it. But he made a separatable algorithm so that you can actually in real time, on demand, generate SDFs for your 16,000 character internationalized font. And therefore, we now have a fully flexible floating point zooming of our entire UI. A lot of the UI that you see here is just the recent developments of Sebastian designing it. The goal of this tool is to be his primary workflow. And I will not accept anything less. Just like this IDE is supposed to be my primary workflow, and if it isn't, what am I building, right? It's like if you can't make a tool your primary workflow, then you didn't build a tool. You built a toy. And even though I like toys, I still would like it a good tool to build toys. I'm a bit sad about. It's just too much stuff on my screen now. Let's see. The MakePad Studio. So the MakePad UI framework that I was scrolling through a little bit, has a slight look like HTML. It's a prototypically inherited object structure that is in linear memory. So it's not a tree, it doesn't have pointers, it's a single vector. So that means that I can do very fast expansion and do the inheritance in the document. So it's like JavaScript, except it's done at initialization time. And then I can instance all these components from that data structure. And instead of the React or reactive model where you write code and interleave code with UI, it is using a query model. Because as you can see here, the whole UI needs to remain a document that is editable in a visual tool, right? The whole UI needs to be essentially a serialized file of a design tool. Otherwise, it will never be able to keep the designer there. If you start mixing code in there, it's going to break the designer. And I have no idea how to do that. And actually, almost nobody has. That's why we don't have good design tools or not very functioning design tools for a lot of the UI stuff out there. So this is a hard choice. No code in your design structure. Okay. What can you do then? The only thing you can do is queries. So jQuery. It was actually a decent idea to prod at trees with, and this is why all of the UI button click connectivity between the Rust code and our DSL is using queries. And to me, I actually find that pretty nice. Let me show a single example. This is why you need a 57-inch screen for your design tool. Although you can do tab switching, but that is not as nice. Simple app. Here you see the query. So I tried to condense the query in Rust as much as I could, but you say UI.button. This is an extension trait that queries for buttons with this query, and then you can check if it was clicked. And the great thing is that this is not a closure, is that closures are actually not so nice in Rust because you have to deal with the mutability of your data. If you can make it a single if, it's just a top-down flow. And I have zero data locking problems. Okay, I have some more to show you. Anyway, my idea for the future of this is a new idea. Uh-oh. Oh, this is positive. Bright blue sky. This is like, what is it from that movie? You Are All Bugs? Series. Anyway, so tool-assisted instancing. So composition in UI is actually... Okay, anyway, this is maybe I'm going to stop this right now. There we go. We're going to look at a blue sky. Nice Windows background. 1 minute. So tool-assisted instancing is the idea that instead of using coding inheritance, maybe we can use composition from a code generation point of view, like a Git structure. So you can clone something, but because it can just compare the clone, you can solve the inheritance of these things without the fragile base class problem. Oh, and Eddie's achievement is that he built a Wasm engine called Stitch to minimize our compile time. Because I was like, let's use a Wasm engine for syntax highlighting so we can load syntax highlighters. And then MakePad became 25% of the build time, and that's just not acceptable. So Eddie, 6 months ago, decided to build a Wasm engine, and he finished it recently. It's the fastest Wasm interpreter in the world right now, I think, slightly faster than Wasm 3, written in Rust, and it's spec compliant and fuzz tested. So yeah, I had a demo for embedded Rust because we're going to do a workshop this afternoon. Let's see if I can run this thing. This is another big if. This is an ESP32 RISC-V that is running Rust, and I'm going to start it up. Let's see, ESP car. Oh, there we go. Come on, ESP, connect to the Wi-Fi already. Oh wait, maybe it already did. Maybe I don't send key presses in my IDE. There you go. Yeah, so that's embedded Rust today at 2. And you get a free dual microcontroller, Raspberry Pi RISC-V to play with. And we're going to build a connectionless chat room with a MakePad UI. So yeah, that's it. Thank you.
Now, of course. Yeah. And now, of course, it's time for questions. Somebody will be walking around with a mic. Can you wave your hand? We say, Lucas. There we go. That's the first question over there.
What shading language were you writing your shaders in for the Mandelbrot thing? Looked like Rust, but...
Yeah, it's essentially a type inference GLSL that looks a little bit like Rust. I just decided to make my own syntax because it is something that I wanted to be easy for UI. So here, for instance, you see that we have structs with methods in shaders, and we have a module system. And so you can make a standard library that has, for instance, SDF primitives that you can just draw like it is a canvas, like circle. But underneath, it's doing all the math and it's using a stateful struct. But having my own syntax allowed me to, as I say, unsuck it a little bit. Because GLSL is really not a modern language in terms of modules, in terms of all the things that Rust brings, type inferencing, like this type inferences. I mean, Eddie built a type inferencer. This is why Eddie does the hard things. Like, Eddie, could you build me? I built a type inferencer once, but you know, it wasn't as good as his. So
nice. Anyone else have a question? Yes, all the way in the back.
Hello. So I tried MakePad a year ago, and at the time can say it was heavy in development. I seen, and what I was surprised the most about is that I had to pass the redraw calls everywhere. Now I look at the tutorial. Oh, now congratulations on making the tutorial. It's cool. And the redraw calls still exist, and I still need to pass them down. So what's up with that? Why do you have to do that?
Why do you have to redraw?
No, not redraw, but explicitly pass redraw events to the widgets from parent widgets.
Oh, well, that's because MakePad, might have mentioned that, should have mentioned that, is a hybrid retained immediate mode API. So one of the problems with UI rendering, UI frameworks, is that they always assume one or the other. Either it's immediate mode, like eGUI or ImGUI, or it's fully retained, like, browser DOMs. But as you build widgets, like as you build this code editor, right? Or design tools or log views that want to have millions and millions. This log view can process, you can blast at it in a dense for loop. You can print and it doesn't crash. Because all of these widgets are essentially immediate modes. They just have a viewport on the data and they draw it. In that draw call, of that widget. But the widgets can be combined in retained mode trees. So you can choose whether or not you want to use the retained mode structure or the immediate mode structure, depending on your use case. And I think that is absolutely required if you want to build something like this. Because if you have to do the code editor in a retained mode API, we tried, right, with Cloud9. I'm not going to ever do that again. You want immediate mode drawing APIs for actually most of the complex widgets that you do. But you still want to, for instance, you can have an immediate mode list, right? So there's data coming in and you draw the list, but then you can instance the retained mode substructures out of the DSL, right? So you can just mix and match.
Next question over there.
So this is a question from the live stream. In terms of compilation time improvements, do you think that Cargo needs more attention in this respect, or Rust C, for example, in relation to features and dependencies?
I think if you want to have fast build time, you need to change your attitude of how you deal with dependencies. So, no left pad. I'm sorry. No random convenience libraries just to make something green in your console. You know how to write ANSI. You don't need a library for that. And the other thing is we need to change the way we do platform import libraries, like the Windows RS example. But BindGen is completely architected the wrong way around. For instance, I've written all of the Linux stuff, like ALSA and Pulse, and this is the not so fun part of doing this. And what I did is I would run BindGen, open that in an editor, get the whole 100,000 lines of that header, and then just see what I needed and just copy that into my file. And on average, I was left with about 3% of the code that BindGen generated. So the whole syscrate thing we have in the Rust ecosystem just needs to go. It needs to change around. BindGen needs to generate sys modules. So that, because Rust does that just fine with C, extern C, and it links automatically. So there's no problem whatsoever. We just need to change how we do that. And and I hope that foundational crates just start shedding their dependencies. Just like the Wasm engine, all of a sudden we were like a quarter of the build time, and I had to lose my co-founder for 6 months to build a Wasm engine that builds in 1 second. It's 15,000 lines of code. Or actually, it is in MakePad Studio. That 8 seconds includes the Wasm engine. I didn't even notice it because it's at the end of the pipeline, so I had plenty of cores left, so it just vanishes in our build time right now. That's an approach. I think that's a cultural change. If you want, I'm not saying everybody should. I want it, and that's why I cannot use very many things from the Rust ecosystem, because everybody just piles on stuff. Like, for instance, I wanted to use OpenSSL for a WebSocket, and I was like on Linux, okay, OpenSSL crate. And that thing that rolls in sin and quote, which I don't want in my code base because it takes a long time to compile. For a proc macro for documentation okay, all right, I'll have to do OpenSSL the way I did all the ALSA things as well, which I really don't want to do. And I wish that the ecosystem would do that out of their own ideas. But yeah, Cargo is not the problem. Rust is not the problem. It's us.
Now, based on that's a good closer actually. But does somebody have a question or a comment based on that? Yeah, see, I thought all of the hands were going to go up now, but okay. Last question, there in the back.
Okay, so you've already answered the question in one direction. So you said why you don't want to use other people's libraries, but have you thought about encouraging people to use your libraries, making them modular so that other people can use them?
So MakePad is essentially a giant tree of 50 crates that we wrote ourselves. But my goal is to build Visual Basic in Rust or whatever. That's my goal, right? My goal is not to maintain 1 million crates as a maintainer of that crate, and that's my thing in life. I don't, my job is to build this product, this tool. So in that sense, when I make my own crate, I make it do exactly what I want, and I'm not necessarily super interested in supporting that for everybody's use case, because inevitably that's going to weigh it down. So this is why I'm saying, like, the platform crates should just be generated on demand as you use it. That already cuts out a huge amount of community crates that are no longer needed. Some crates that we made, like we have the regex engine that Eddie built last year, because otherwise he wouldn't use the editor. He was like, I need regex. I'm like, okay, guess what you get to make then? A regex engine, because the regex engine we had didn't compile fast enough, I thought. So he built a regex engine. It's almost in there now. But those kinds of crates, like the things that Eddie built, I think are absolutely, like the Wasm engine, absolutely useful for the entire ecosystem. But I would not recommend using some of the things I wrote in there. Not all, but like some of the things I wrote in there. So, yeah.
All right. Well, thank you very much, Rick Arends.